Alright, so today new challenge. So this one is add one row to a binary tree. And so I gave an example. So for instance, we have this binary tree 4, 2, 6, 3, 1, 5. And because we want to add the value 1 at def number 2, it will produce this tree. So how to do that? Simple logic that I want to implement is just find the parent node and then once they're found I insert my new nodes. So if I give on this example, I have parent node will be, so def2 here in this example is this row. So then the parent node is 4, there is only 1, and then I'll add then 2 new nodes, 1 and 1, and make sure to link the previous ones. And so to do so, I created some test function. So this test function just recreates the binary tree I just showed here, and what it does, it will make sure that with this given input I will get this back. And that's pretty much. Also created that function above just to print a binary tree. So this one is a pre-order traversal, and it's used in the test. And yeah, so let's get started. So I will do that. So I'll create a function that will be get all parents, and they will. So I'll give the tree and a def, because I want to have only the parents node. So it will return an array of nodes, of parents nodes, or process node. No. So I have to create that function. Create here all parents. So this function will take a tree as an input, the root of the tree. So in that case, tree node, and it will also get a def, which is an int. It will return just an array of tree nodes. So I use a pointer, so because I don't want to lose the reference of the nodes. Alright, so return, for now it's nil. And then what I have to do is I have to do like kind of a BFS. I'm going to go over every node, and then I will add them to a list, a slice in Go. So I'll make that list, the one I just talked about. Alright, and then need a stack also to do the BFS, and it will be, and I'm going to create a new data type, I guess, to just know what's the depth of every node. So I'll create it here, type struct, and then it will contain a node and the depth. So node, tree node, and no. Yes, and depth. Okay. Right. Then what do I need? Do I need something else? I need to initialize my first tree.def struct. So the first, so because this row is at def2, so the root will be at def1. So this is what I'm doing here, and then I need to initialize the stack with the first with this tree.def. So I'm going to do append stack TS, and so then I have my stack and I can do the BFS. So it's for as long as there is something in the stack, I just need to pop things. So and then every time I just remove the first element from the stack. So I do something like this. Yes. No. Yes. And so I pop the first. I mean, I pop. I go to the. I get the first element. So it will be stack 0 def, and then in this case it will return 1 right in the first loop, first iteration. Then I get the node, so it will be same thing, but this time with node. And then I do if node left is not null, I will add to a stack, and I do the same for the right pointers. Right, and then so I just add to the stack, yeah, and I use, and what I do is I add, so I need to add the tree node, so left, and the depth is t+1. Okay, so I have to do the same, but this time the right one. Right, okay. And what I want first is to get the parents. So the parents, how I get them is just by knowing at which depth we are. So depth -1 in that case, because I want to have the parent. So something is not correct here. What's going on? Alright, this is because I don't choose it yet. Okay. So then I add to my list, append, and I add the node. Okay, so this should be good. And I return something. Of course, I returned parents. Alright, so now this function should be good. And I need to do that one. So for that one, I just have to go through all the parents nodes. So in that case, it will be up element of the list, the range, and what do I need? I need to create nodes and add those nodes and link them. So let's create the node first. So the new node will be tree node, yes, and it will have the value that we want. So will be the value, and now I need to link it. So how do I do that? Oh, so I know. Okay, so I know that I have the parent. So the child will be, the live child will be actually this, and what I need to do is I need to then add it to the new node. But first I need to change the child to being the new node. So now what I've done is basically change the 2 here by the 1, and now I need to like link the 2 back to, link the 1 pointer to the child. So then the new node left is going to be child. Alright, and then I pretty much do the same thing for the right side. So I don't like to copy paste because I make mistake, but let's see. So new node, right, this is right, and this is right, and this is right, and this is not used, so I need to use it here. Okay. Alright, so that should and I return something, so I need to return the root. Okay, so looks good so far. Let's see. Let's run my test. It failed. Why? Do I know something? Okay, so expected is this one, and I get this one. Oh, I think I know why. It's because the depth is 1 in that example, so then it means that I don't get anything from the parent node. Let's see. I don't see that. Yeah, because the depth is 1, so in that case, yeah, I won't get any node, because here it will be 1 minus 1, 0, and yeah, so I need to manage that use case. So if def equal 1, then what do I need to do? I need to create a new node. Yes. Then, or in that case, I just need to add it to the left. It's just a use case on the example, on the original question. Node, and then I return. Yeah. Still, so it's not that. So what it is? Let's see. I thought it was going to be that. Oh no, because the depth is 2 here. Yeah. Yes. Okay. So what did I miss? better understand the issue. So it looks like when I run the test, first is correct, because 4342 is like 41231, 41231, so this is good, and then it doesn't work for the last three, and so it looks like the right side is not working, and this is because it should be this one. If I rerun the test, now it's working.